Here's problem 31.5. A square coil, length of side 24 centimeters, of wire consisting of two turns is placed in a uniform magnetic field that makes an angle of 60 degrees with the plane of the coil. If the magnitude of this field increases by 6 millitesla every 10 milliseconds, what is the magnitude of the EMF induced in the coil? Alright, this is a little bit harder because we have to visualize that the fact that the magnetic field is at an angle with respect to the coil. So let's imagine a three-dimensional system here, and we have our coil in the YZ plane, and the length of the side of the coil is 0.24 meters, so the area of this coil is going to be 0.24 meters squared. And what is that? .0576 meters squared. Okay, we're also told that this field changes 60 millitesla every 10 milliseconds, so our change in field is 60 millitesla, and our change in time then would be 10 milliseconds. The angle between the magnetic field and the area, the plane of the area, is given as 60 degrees. So let's imagine that we would have a magnetic field coming out like this with an angle of 60 degrees with the plane of our area here of this coil, and the number of turns of our coil is 2 actually, so let's not forget that. Now when we define flux for a planar area like this, it is the field times the area times the cosine of the angle between the area vector and the field. Now I called this angle 60 degrees. I shouldn't have done that. Well, let's call this new angle alpha, like this. Because as we look at, what we want is the angle between the magnetic field direction and the area vector. Now the area vector is coming normal to the area like this. So the angle we're talking about is actually this angle right here, which would be 30 degrees. So the angle in question then is we're going to have the field times area times the cosine of 30 degrees, not 60 degrees. Okay, our change in flux will be, since only the field is changing, that's going to be the area times the change in field times the cosine of 30 degrees. So our EMF induced, at least the magnitude of it, will be the number of turns times the magnitude of the change in flux over the change in time, and that's going to be the number of turns times the area times the cosine of 30 degrees times the change in magnetic field over the change in time, magnitude. So this will be 2 turns times 0.0576 meters squared times cosine of 30, and then we're going to have a change of 60 millitesla in 10 milliseconds. The millis cancel out, and so we have 2 times 0.0576. Cosine of 30 is 0.866 times 6. And what does that give us? That gives us 0.0599 volts, or 0.599 volts. So that is the induced EMF in the coil at this angle while the magnetic field is changing in that way, 0.599 volts.